This is our final lesson for physics calculation, and we are looking at the second question under Coulomb's law. So the question here reads 2 charges plus 2 times 10 raised to the power minus 8 coulombs and minus 8 times 10 raised to the power minus 8 coulombs experience a force of attraction of 1.8 times 10 raised to the power minus 3 Newton. Calculate the distance between them. Alright, and they gave us the constant. They said we should do what? Calculate the distance. The former one we just solved, they told us to calculate force. Now they said distance. Alright. You know the Coulomb's law now, where F is equal to KQ₁ Q₂ over R squared. Now we have to find this distance. Okay, if we make distance the subject of the formula, we are now going to be left with R. The square will come out. It will come down to square root. It is here KQ₁ Q₂, okay, over the force that should be here, force. Okay, so this square now turns to square root. All right. So this is the formula we are going to use to find what? The distance. So first of all, let's look at all we were given. Okay, let's write them down here. Okay, so giving what? They told us to find what? The distance between them, R equal to question mark. They gave us what? 2-point charge, Q1 equal to this, plus 2 times 10 raised to the power minus 8 coulomb. Then Q2 equal to this, Q2 equal to minus 8 times 10 raised to the power minus 8 coulomb. Alright. Experience a force of attraction. This is the force, 1.8. Force equal to 1.8 times 10 raised to the power minus 3 Newton. Everything just dey well, all the units just dey well. They can still give us weighting K, constant of Coulomb constant, equal to 9 times 10 raised to the power 9 Newton meter square Coulomb square. Everything just dey in order. Okay, everything dey in order. No need for any conversion. All we need to do now to just substitute. Okay, R now is equal to root. Okay, root. What do we have here? K. K is what? 9 times 10 raised to the power 9. Okay, what else do we have? Q1. This is the Q1 times Q1 is what? 2 times 10 raised to the power 2 times 10 raised to the power minus 8. Okay, then which other one we get again? Because it gets charge 2, second charge, times 8 times 10 raised to the power minus 8. Okay, so over force. What is the force? 1.8, this one, times 10 raised to the power minus 3. You see what this Jamb they do? They don't pack everything put for standard form. All this kind of thing with the delay. 9 minus 8, we'll do this power. 9 minus 8 will give us waiting. It will give us that's 1. Okay, so minus 1. So minus 1 minus 8, that will give us minus 7. Okay, is that not minus 7? So that should be minus 7. All right, so minus 7. Okay, so what thing will happen? Make we calculate this up first. Okay, get our answer first of all. We'll calculate this up, then get the answer. First of all, now this one resemble wetin go dey easier for me. It resemble wetin go dey easier for me. Okay, so if I move leave this power first. So if we do 2 times 8, move do the charge first, this 2-point charge. If we do 2 times 8, we will get 16. So maybe put them as 16. Okay, then times 10 raised in power of waiting minus 8 plus minus, or minus 8 minus 8 will give us waiting minus 16. Abi? Minus 8 minus 8 will give us waiting minus 8 minus 8 minus 16. Okay, and we need to turn this into two significant figure. Okay, so equivalent to, if we convert this into significant figure, we put points for here. We put points for here, we'll come minus 1 from this 6. This 0 with here, so minus 1 for here. It will come be 1.6 times 10 raised to power minus 15. Okay, so this one will be our 2-point charges. Okay, so Q1, Q2 equal to this. Okay, 1.6 times 10 raised to power minus 15. Okay, then we'll come add, we still do the numerator. We'll come do this one join now. Okay, we are now going to be left with this one, 9 times 10 raised to power 9 times this one. The point charge is 1. Go add the point charge. No, say we don't get the numerator. Remember, say we get square root, or say we get roots. Okay, 1.6 times 10 raised to power minus 15. So with this now, if I calculate the power separately, I will be left with the power will give me plus 9 minus 15. Okay, now times. Okay, we're going to get minus 6. Okay, equal to minus 6. Okay, so the power now for this numerator is minus 6. So we're going to do 9 times 1.6. That 9 times 1.6 will come give us 14.4. Abi, then we're going to bring this one enter times 10 raised to power minus 6. So this one is the numerator. Everything with the up here, now be this one. So we are now left with everything with the here, numerator, and this one, so the denominator. So make we carry this one, go the other page, make we solve and finish for them. We are now left with r is equal to root. Wetin be the numerator wey get us now? 14.4 times 10 raised to power minus 6. Abi? Yes, over 1.8 times 10 raised to power wetin? Minus 3. So we don simplify and reach. Okay, so we need to do another power here again. Okay, we need to do another power here again. This one minus 6 minus 3. Okay, because say over dey here, we go need to do wetin? We go need to minus. We need to minus. Okay, is it supposed to be minus 6? This thing we are supposed to, since all of them dey say all these things, look at this thing. All these things dey two significant figure. We no fit go dey include 3 significant figure dey join am. So we go need to dey convert everything na 2 or 1 significant figure na dey dey. Say 1 significant figure, 2 significant figure. We no need to dey introduce 3 significant figure dey enter here. So this 14.4 times 10 raised to power something, make we convert this thing to 2 significant figure. If we move this point come here now, maybe 1.4, we go need to minus 1 from this 6. It will come be 14. Sorry, it will come be 1.4 times 10 raised to power minus 5. That we'll come use for that root. Okay, so let's write it out again. R is equal to root 1.4 times 10 raised to power minus 5 over 1.8 times 10 raised to power minus 3. Okay, so we'll do the power. If we do the power, minus 5 minus 3. Just know say when you get over for here, now minus you go minus. You minus the up power from the lower power. And so they take the do one according to the indices. Say you use one base, you will carry one base like this 10 raised to power minus 5. Put that for inside bracket minus 3. Nothing concern all this plus and minus sign for here. Just do the minus. Then you can include the sign of the bigger one, which is minus. The answer what you get for here will be in minus. Because the bigger one for here carry minus. You understand? So this one will come give us minus 2. Alright, so the power is minus 2. 10 raised to power minus 2. Alright, so R is equal to root. What are we going to get? If we do 1.4 divided by 1.8, it's going to give us 0.8 times 10 raised to power minus 2. What is the square root of 0.8 times 10 raised to power minus 2? Or maybe we convert that to waiting to decimal. 0.08. Abi? 0.008 times 10 raised to power. Which one come be times 10 raised to power? Now this one be the figure. What will be the square root of this 0.008? If you check out for your calculator, you will get R is equal to 0.089 meters. Abi? No be the distance we dey calculate. It should be in meters. Just let's check if we got anything correct. 0.08 for option C. And we get 0.089. That's about 0.09. Oh, but now to pick the closest option. Wait oh. But is this actually the square root of this thing? The square root of 0.008. Is it 0.089? How is that possible? I don't know what this calculator they give. Please punch square root of 0.008 in your calculator. And drop it. Look, just check if you have the answer should be here. I'm suspecting this 0.02. That's what I'm suspecting. I don't know. But just punch in your calculator and drop it in the comment section. Let me see. This calculator, I don't know what they worry on.